Welcome back to Security for Legal SaaS. I'm Alice.
And I'm Dan. Episode 38, LLM API Key Isolation and Inference Gateways. Alice, I'll be honest, when I first saw this topic, I thought, how much is there to say about an API key? It's just a password for a service, right?
It's a credential, yes. A long string of characters that proves your application is authorized to use a service like OpenAI or Anthropic. We covered API keys way back in episode 3. But here's why this deserves its own episode. There's now a named attack category called LLM jacking, coined by Sysdig's threat research team. It's exactly what it sounds like. Attackers steal your API key and hijack your access to cloud AI services, and the economics are brutal.
How brutal are we talking?
One startup had a $400 a month OpenAI bill. Their API key ended up in a public GitHub repository for 11 days. The next invoice was $67,000. The attacker had been running commercial AI services through the stolen key for over a week. And that's a small case. Sysdig documented attacks costing over $100,000 per day when targeting enterprise accounts with access to models like GPT-4 or Claude Opus.
Right, and for a law firm, the cost isn't just the bill, it's every prompt that went through that key.
Exactly. Every prompt your legal AI sends contains something. A client name, a contract clause, a case strategy question, a privileged communication. If the attacker has your key, they can set up a proxy that logs every request and response flowing through it. The financial damage is real, but the data exposure is the existential risk.
So, how do these keys get stolen in the first place?
The usual ways. Hard-coded in source code that gets pushed to a public repository, stored in environment variable files that get committed accidentally, left in CI/CD pipeline configurations, shared over Slack or email. And here's one that's newer. In March 2026, a popular open-source LLM proxy called Light LLM was compromised. Attackers hijacked the maintainer's account on PyPI. That's the Python package repository, and pushed a version that silently exfiltrated cloud credentials, SSH keys, and API keys. Light LLM had 97 million monthly downloads. Because it runs as a centralized gateway, compromising it gave the attackers access to LLM API keys for every provider its users connected to. OpenAI, Anthropic, Azure, all of them.
That's a supply chain attack on the infrastructure that's supposed to manage the keys.
Which brings us to the solution. And the irony. The right architecture is an inference gateway, which is conceptually similar to what Light LLM does. The difference is how you deploy and secure it.
Yeah, walk me through what an inference gateway actually is.
Think of it as a proxy layer between your application and the LLM provider. Your application never holds the OpenAI or Anthropic API key directly. Instead, it authenticates to your gateway using internal credentials, a service token, an MTLS certificate, a kind of internal authentication we covered in episode 15. The gateway holds and manages the provider's API key. Every request flows through the gateway, which adds logging, rate limiting, budget controls, and policy enforcement before forwarding the request to the provider.
So if someone compromises your application, they get an internal token that only works through your gateway, not a raw API key they can use from anywhere.
Exactly. And the gateway gives you controls you don't have when your application talks directly to the provider. Hard budget caps. Not just alerts, but actual request rejection when spending exceeds a threshold. Per user and per team rate limits. Anomaly detection. Someone making 5,000 API calls at 3 a.m. when no attorneys are working should trigger an alert. And critically, the gateway is where you can intercept prompts and scan them for sensitive information before they ever leave your network. That's the redaction pipeline we'll cover next episode.
Right. What about key rotation? I know from episode 30 on secrets management that you should rotate credentials regularly. How does that work when your whole AI pipeline depends on one API key?
This is one of the biggest advantages of the gateway pattern. Key rotation happens at the gateway level, completely invisible to your application. You generate a new key from a provider, Add it to the gateway configuration alongside the old one, verify it works by routing some traffic through it, then remove the old key and revoke it. Your application code doesn't change at all. It still authenticates to the gateway with the same internal credentials. Compare that to rotating a key that's hard-coded in 15 different microservices. That's a deployment event. With a gateway, it's a configuration change.
Yeah, so the first principle is per environment isolation.
This should be obvious, but it still isn't in practice. Development, staging, and production must each have their own API key. A developer's sandbox key should have a hard cap of maybe $50 a day and should not have access to production-grade models. If a developer's key leaks, and developer keys leak constantly, the blast radius is a small bill and no exposure to production data. The production key should be locked down with the minimum permissions required. If your application only uses one specific model for contract review, the key shouldn't have access to image generations, speech to text, or any other service.
Principle of least privilege applied to AI services.
Exactly what we covered in episode 8, now applied to a new category of credential. And store these keys in your secrets manager. HashiCorp Vault, AWS Secrets Manager, whatever your firm uses. Not in environment variables. Not in configuration files. Definitely not in source code. The gateway retrieves keys from the secrets manager at runtime, and the keys are rotated on a schedule. Microsoft filed a lawsuit in January 2025 against a criminal syndicate called Storm 2139 that had built an entire commercial hacking-as-a-service operation using stolen Azure API keys. This is organized crime, not script kiddies.
For someone building a legal AI tool today, maybe a contract review platform or a research assistant, what's the minimum they should implement?
3 things. First, separate keys per environment with hard budget caps on each. Second, an inference gateway. Even a simple one using an Nginx reverse proxy with basic auth, logging, and rate limiting. Third, never put the provider's API key in your application code, or anywhere a developer can see it in plain text. Those 3 things would have prevented most of the LLM jacking incidents we've seen.
Next episode, redaction pipelines for cloud AI. How to strip sensitive data from prompts before they leave your network.
Until then, I'm Alice.
And I'm Dan.
Security for Legal SaaS is a series written with AI assistants. Alice and Dan are AI-generated voices. No professional advice here, just education.